Hey guys, welcome to another how-to video. So this week I've been doing a lot of optimization. I've been running my packaged builds, both development and shipping, on a test PC that I have. It's the same PC that I bring to events and shows to demo the game at the moment. And it's a pretty typical PC setup that kind of most accurately represents what PC gamers, the average kind of PC gamer setup. Prior to that, I've been testing everything out here on my workstation, which is a bit deceptive because the specs are pretty high, as you could imagine, on the workstation. So with that said, I've been doing a lot of optimization with the goal of getting a steady 60 frames per second throughout the game. So through my own experience and through my research I've done online in the last 2 weeks about optimization within Unreal Engine 4 and in general optimization, I'm going to kind of quickly go through everything. This isn't going to be like a really in-depth video. I'm kind of going to assume that you know a lot about everything from texture quality, that you know how to create LODs, that you're aware of the different lighting techniques within Unreal, and that you know how to create widgets and kind of know your way around things. This is kind of targeted at those who have kind of got a project up and running, or people who are kind of just kind of want to know kind of where to start with optimization within Unreal. So with that said, let's talk the basics. So I'm going to bring up a web page here. I'll leave a link to it in the description. It's Unreal's Unreal Engine's homepage, and it's basically a list of all the stat commands that you can run within the editor. Stat unit and stat FPS are kind of the most common ones, but there's a whole list of different stat commands you can use here within Unreal. These will help you kind of track how much memory usage, how long things are taken to draw, and all that good kind of stuff. So moving on from that, in general we want to kind of think about our specs from day one. Now, I've always kind of would err towards a PC that has quite similar specs to consoles. That way, even though you're targeting PC, that if you do want to go to console in the future, it's a little easier. So let's take a quick look at the PS4 and Xbox One specs. So as you can see, we're going to go with the PS4 vanilla. We're not going to look at the Pro or the other higher end variants. So its memory is 8GB DDR5. We don't mind, we won't worry about the DDR5 part at the moment, but one thing to remember with this 8GB is it's shared. So at no point is some of it dedicated system RAM and others dedicated graphics RAM. This 8GB is shared. We'll get back to that. Also, here we have the Xbox family of devices. Again, we're looking at the Xbox One vanilla. So it is 8GB DDR3. Again, we're not worried about the DDR3 part, but we are concerned with the 8GB. Again, this is shared RAM, so it's used for both the system and graphics, textures, things like that. You may notice that the CPU, and this is an 8-core. We're not really worried about the branding, and again that the main processor in the PS4 is an 8-core, so multi-threading, keep that in mind when it comes to the stack. So with that being said, we can kind of take those specs over to the PC and say, oh, well, okay, most PC users are going to have, who are gamers, are going to have 8GB of RAM or greater. But with that in mind, we're targeting 8GB of RAM, to keep that in mind. Again, I may just drop in the word textures every so often to emphasize how important it is when it comes to textures keeping your file sizes down on your textures and your compression, as lossless as it may be, as close to what you want. So with that said, it's definitely worth looking at all the stack commands. We're going to be using some of them now in the editor, but definitely have this page open, study it, figure out which ones are most pertinent to you, and get to know them inside out. Major thing to remember is from day one we should be culling on our static meshes, setting up reasonable cull distances for everything. Like these rocks will have a cull distance starting from a minimum of 1,000, and they're gone when we get to 10,000. Other things like that of that size you want to be culling basically as often as possible. Another thing worth noting is that if we go into our levels, and okay, so here, this is world composition. That you should really get used to if you're going to be doing a lot of open world games, and it's used for handling all our streaming. So you may notice that main menu has a streaming distance of 100. The level, which includes main menu, is way down underneath the world, where you're never going to get to it, so you're never going to actually stream in the main menu. Main maps, they have a streaming distance of 50,000 Unreal units, so when we get within 50,000 they're streamed in. Everything else 50,000. I will be adding another layer to this for inside houses, so that we can stream in sub-levels that contain the details inside houses. So let's say we're here, which is about maybe 6,000 units away from the house, that we'll be streaming in only when we get close to the houses are we going to bother streaming in their contents. So it's well worth checking out world composition and making sure that your levels are streaming in accordingly. With that said, some things you want to keep in your persistent level. So for example, I'm going to unload that map, so you can see I have quite a few objects that are in the persistent level. All kind of foliage and kind of landscape assets are kind of kept in the persistent level, whereas everything else is culling and streaming in, and kind of religiously we stick to our distances and make sure that we're getting rid of stuff as much as possible. So with that said, let's take a look at some of the things you can do to kind of give you a good idea of how things are going inside your level. So Alt-P, and you can see that I already have some commands here up. So I have shadows, and up in the top right hand corner I have frame, game, draw and GPU. So they're my units, and above that I have the FPS. So I created a little menu for myself, a debug menu with all these different guys on it. So I'm going to hide all of them, and I'm just going to enter them in via console commands. So the first one we want to take a look at is stat unit. So if I type in stat unit, you can see that those guys are back. So I might try and zoom in on these for you. So we have frame, game and GPU. So as you can see that frame and GPU are pretty much in around the same time, because each frame is obviously waiting for the GPU to finish its calculations, so it's bottlenecked there by the GPU. All that said, 9-point-odd milliseconds is actually pretty good. So the next one to look at is draw. Draw time is 0.6, going up to just over 1 at times. So that's pretty good. And game then obviously is lower than frame and GPU because it's actually not really waiting on anything. So with that said, if you notice that your GPU time and your frame time are okay, but your game time's higher, then I suggest that you probably have to look at your game thread, your CPU thread, which most commonly means that either your code is very inefficient, your blueprints are inefficient, or you have a lot of things on tick. So you want to keep as many event ticks out as possible. Try not to use event tick. It's going to add to your game time there in the units. So ideally what you want to see is frame and GPU in around the same time, and your game thread lower, at least 50% of what the other two are. If you can keep all of the above under 10 milliseconds, then you're onto a winner. So the next one to look at, which is a bit more basic really, once we get a hang of stat unit, then stat FPS is probably a bit more basic, but again it gives us the average out of the draw time between frame, game, draw and GPU. Gives us an average of that, and it tells us how many frames per second we're doing. So I'm over 100 there. Again, this is in the editor, so you can expect to see higher FPS than you will when you're actually in the build. And we're going to have a look at a build later on. Also, we can use stat unit graph, and that will show us a oh, maybe it won't. Stat unit graph. And down in the bottom left hand corner we get a graphical representation of both frame, game, draw and GPU. So you can see them designated by their different colors there. So if I walk around, we're looking for spikes. Really, we haven't that many spikes. I've removed a lot of trees and done some optimization around here that will kind of control that. As well as removing trees, I've optimized some of the shadows, some of the dynamic shadows and things like that. So they're worth looking after. So again, if we want to get rid of any stats at any time, we can go to stat none, and that should clear our screen of all the stats. So okay, we're going to have a look at another one of the stats here from the Unreal page. One very useful stat is this guy here, stat scene rendering. So let's bring up stat scene rendering and have a look at it. So I'm literally going to cheat here. I'm going to copy that, jump back into my editor here, play in editor, and I'm going to paste in stat scene rendering. So here we go. What I like about this one is we get these little red bars that kind of tell us what's going on. So render view family, we're getting 4.5 milliseconds, but basically you can go down through the list there and it'll give you a great idea of where things are being spent. It's a great one really to kind of check, and it's well worth checking regularly from day one. It's not something you want to be delving into too late in your project. You want to keep an eye on what's going on in here from very early on. So again, we're going to go to stat none, clear that, and I'm going to show you a quick look at something that popped up earlier on. My little menu here. So I have a development debug statistics menu. So in here I have a lot of the commands that you would have seen if you visit the link below to the Unreal Engine page, where it shows you all the different stat commands. One that I like and is pretty handy is stat game. So let's click on stat game. So stat game basically, as I said before, if we bring up the menu again, and I'm going to bring up stat unit. So stat game is useful if we see our game draw is, you know, out of sync or higher than frame and GPU. Actually, it might be higher than frame, but if it's higher than GPU or draw, then we want to come in here to stat game. Stat game basically will tell you all about tick. So we have world tick time, 2.5 milliseconds, tick time actual, 2.5 milliseconds, and it shows you a call count on every one of them. So in blueprint time we have 18 calls on tick. In character movement we have 1 call. And basically in the movement component then, that's one call. Post tick component update, we have one. In update in transform or render data, we have 28. In update camera time, we have 1. In blueprint latent actions, we have 30. So this can be a great way of finding out where your ticks are happening and where you need to get rid of tick. At the end of the video, we'll come back to this. I'll show you exactly how to get around using on-tick events, because they're very costly and you want to keep them to a minimum. So okay, rather than run the commands like I showed you earlier, I have them all hooked up here to little buttons in this widget, so I'm going to hide all my statistics. The next one we want to kind of have a look at is, if I bring up my menu, is streaming details. So streaming details, we click on it there. So this is a good idea of, gives you the amount of call counts, where your streaming is happening. So okay, we can see there that as we came around the corner and it streamed in some trees, we got a spike in the graph. So that can be good for if you're walking around a level and you want to see where those little hiccups in your frames per second are going to happen. So you're going to have these, if you want a steady frame per second, then not only do you have to keep your draw counts down, you actually have to kind of ensure that when you come around a corner into a forest or something like that, where there's a lot of actors being rendered, that you're not getting a spike in your performance, you're not getting a hit. Can be unavoidable later on in a project. Sometimes it will happen where you're going to drop 2 or 3 frames, but the idea being that if you can manage it, you're only going to drop 2 or 3 frames. You're not going to notice like a 10 frame drop or like a 15 or 20 frame drop. It's all up to yourself. You have to make these calls earlier on, so that you're not building overly complex scenes. Okay, so going back into the menu, we're going to have a look at our next stat command. So I'm going to hide all those. Again, I'm going to go over to the website just so you can have a look at some of the commands as they are. So one that I like particularly is, especially if you're doing a lot of lighting and especially in a dynamic lit environment, is stat light rendering. So we'll have a look at that. So here we are back in the editor. I'm going to Alt P. So right now I have 2 lights in the scene. I have a sun directional light and a moon directional light, because we have a dynamic environment. So here I'm speeding up time, and there we go, we're at night. So I have 2 lights in the scene, one for each part of the day and night cycle. So if I want to see exactly what's going on inside my sorry about that, just had to run out to my dog and take care of him. He was barking at the postman. So yeah, going back here, we're going to take a look at our lighting. So as I said before, I have a dynamic light for daytime and nighttime, but I also have some lights inside these houses for fires and things like that. So we're going to use stat light rendering. So okay, render lights and shadows, call count 1. Direct lighting 2. So it's counting that we have 2 directional lights, and we won't worry about some of the other stuff right now, but you may notice that if I come around here, direct lighting is now at 3, as we have the light from the fireplace here. So that's worth having a look at. Within dynamically lit environments, we want to keep the number of other lights that we use, like the light here for the fire, down. If at all possible, we want to remove their shadow casting and other kind of stuff. But at the moment in here I have some shadow casting going on. But again, if I come out of this and if I again load the level that contains that asset, and I'm just going to browse to the asset, but you can already see that this sphere represents the light, the outer radius of the light, the fall off for the light. Over here I have another one, another house with a light for the fire inside. So what you really want to do is, say we're over here, have the cull distance for that light, so that if I'm by this house, the light in there is not active, and vice versa. If you're going to have two lights in a scene, make sure that these two spheres that represent the fall-offs and the radius of the light never overlap. And you want to keep, basically, if you're using a dynamically lit environment like this, you want to keep the number of lights in your scene below 5. So I have 2 lights here in the village, so I can't have any more at any one time. You can do little things like culling and destroying actors if you want to get a way to work around that. So that's very worthwhile keeping track of. So just as we did before, I'm going to Alt-P to play an editor. This time what we're going to be looking at is I'm going to go into my menu, hide all, go back in, and this time I want to have a look at shadows. Now, shadows are important in the sense that, especially in a dynamic environment, we want to keep our call count as low as possible. You may notice in the forest here we have a lot of trees. If you're going to be adding trees or other kind of objects that you kind of rely on decent shadow quality for, I would have the shadow rendering call stats up all the time, because you want to see how much of a hit you're taking for these shadows. Each dynamic shadow, as you can see, is moving with the time of day, but it also the anti-aliasing of the shadow, how soft and how accurate around the edges of the shadow and the leaves and the details are very important. You can also, in your project settings, control the distance. So you may see that off in the distance there, our shadows are getting culled. We'll just actually do that in the editor, it might be easier. So if you watch the shadows here onto these trees, as I pull back, they start to disappear. So we need to cull our shadows just like everything else. I have the shadow quality of these, which is by default at 1. I have it set to 0.25. So again, we want to, especially because there's so many trees, we want to keep the shadow quality down. So going back in and playing, I'm going to hide those, and the next one we're going to look at is engine. So again, engine covers our call counts and frame times. So you can see that as we're looking away from the woods where we have less detail, our inclusive average should come down. So we're in the village with our back to the woods. If I turn around now, you should notice it goes up. So our inclusive average goes to just over 10 milliseconds. Again, this is something we want to keep an eye on throughout development, so keep these down. If you notice the counters at the very bottom there, we have static mesh triangles. So we have 13 million triangles. Not too bad. Max was up around 15, so we want to again keep as many of those down as possible. Indeed, a lot of those are coming from our grass on the ground, which again is being culled and uses instances in a kind of a smart way, so we're not really worried about that. But you can see as I walk towards an area with very little grass, very little trees, our culls are coming down. So counters very much keeping an eye on all the time. So again, I'm going to go into my menu, I'm going to hide, and I'm actually going to take away something from that later. And this is more PC specific. DirectX 3D 11, so DirectX 11 stats. So we click that. So these are stats that are unique to DirectX 11. So uniform pool memory. So we're using 0.24 megabytes of physical memory, I assume, on our graphics card. So this can be handy, especially if you're benchmarking on different PCs and different computers, to give you an idea of how your performance varies from computer to computer, depending on the hardware specifications of the machine. Again, I would stay away from emulating different computers because of the inherent overhead involved in emulating different hardware setups. You're really going to have to go out there and actually get it onto a computer and test it that way rather than through emulation. So, with that said, what we're going to do now is I'm going to bring up my menu, hide all, and we're going to have a quick look at the widget that I showed you just there, that contains, again, all the commands that can be found on the Unreal website. So just because we had a little bit of trouble with one of the buttons, so again, I'm going to come over here to my project, defull screen that. Now, and I'm just going to navigate to the folder that contains all my widgets. So here we are. So you may notice that's my widget, pretty basic. I'm not going to go into that, but you can see the execute command node. So this is the one that executes the hide all statistics, and rather than have this hide all the statistics and then quit, what I'm going to do is I'm going to remove that. I'm going to break that link. I'm going to go over to my designer, and in this guy here, I'm going to add another button. To my stage, and then I'm going to put it in here. Button's name is going to be exit, and the text for the button. Oh wait, I'll just quickly make the button the same on rollover as the others. So 0 on rollover, yellow. Oh, they're garish, but again, this is something that the player's never going to see. We're only going to cop grief from other developers. So text. I'm going to put my text on my button. Black. Call it exit. Compile, save, and we should be done. We just have to get the exit button, click event, and take this, which was already hooked up to that, and put it to that. So indeed, I could probably, and I probably will, is get rid of all those. So now the buttons only run their corresponding commands, and we have to hit exit to exit. So let's try that out. Hope that I won't delay the video by having got it wrong. So, unit graph, hide all stats, streaming details, hide all stats, exit. Yeah, that seems to work pretty good. So again, probably your two favorite friends are going to be stat unit and stat FPS. So with that said, I'm going to take you on to the next part. You may have noticed down in the bottom here I have CPU profile. So we have a start and a stop button. The commands for those, we'll go into the widget again. The commands for those are basically stat start file and stat stop file. They're to be used when you've created, packaged a development build of your game, and once you have the development build running, you run those commands, and it'll output a file that we can then use in Unreal Frontend. So that's the next thing I'm going to cover. But just before I do that, I'm going to show you another thing, especially if you're considering creating a debug menu like that. Something that's worth thinking about. So, and will save you a lot of time in the future. You can use it in all kinds of other ways. So you may notice on my delete key that I've bound to bring up my debug menu. I have a branch and its condition is packaged for distribution. So if that's false, it brings up the menu. If it's true, it does nothing. So I can have all these debug menus set up for my game, have them sitting there, and I don't have to worry about getting rid of anything when it comes to actually shipping the game or packaging a for shipping build. So with that said, it's well worth checking out is packaged for distribution node within Blueprints. It's one of my favorite nodes. I think I even tweeted out about it when I actually found it a week or two ago. So cool, guys. With that said, what I'm going to do now is I'm going to go package a build. My big build configuration is going to be development, and I'm going to go ahead and package a Windows 64-bit build. So it's just saving some of the assets out. I'm going to go over to my design folder. In here I have a pre-alpha directory for all my builds. In development, let's see, shipping was last at 40, so I'm going to go in here, copy that, and we're going to create a new folder. And since the last build was 40, this one will be 41. So I'm going to select that folder, and we're packaging. So I'm just going to put over my output here to keep an eye on things. And once the packaging is done, I'll come back and show you how to use Unreal Frontend to debug and kind of get more information and analysis on where your bottlenecks are and how your optimization has been going. Okay guys, so we're back. Our build completed, exit code 0, success. So that took about 15 minutes on this machine. So for the next part of this video, we're going to have a look at the profiling and how to examine those profiles in UE4 frontend. For the purposes of this video, I'm going to demonstrate how to do it on this machine, but as I said before, this is my workstation. It's not a very good example of what the end user will be using, so of their specs. So if I was doing this for my actual project, then I probably would get the profile off my test PC. So I'm just going to open up a window here, browse to my my folder with all my builds in it, and we're going to launch the development build. So we might actually get an error here. Yeah, my my antivirus is being a douche. Okay. Okay, so here we are in game. I'm going to hit play demo. So you can see things streaming in. Unlike other builds of the game where I'd have the player occupied or a loading screen up, in debug mode, or in development mode rather, it doesn't come up. So here we should still have access to our development debug statistics menu. I'm going to come out of that for a second, and we're going to run the command. Rather than use the menu, I'm going to type it in. So you guys following at home can do the same. So it's stat start file, and basically you see there we have tells us our profiling is started and stat file duration, so you can see exactly how big in megabytes the file is. So we're going to go to an area that's where we have a lot going on. So we're going to walk up through the woods where we have culling going on in our foliage, a lot of draws, things like that. So we kind of want to keep maybe about 30 seconds of this. So you want to kind of start and stop your file on an interesting part. So I have about a 30 megabyte file now. So I'm going to walk out just to the water's edge. And now I'm going to turn around and go back to the village where I started the file. So once I get down to the stone circle here, I'm going to end the file. But we should gather enough data from this. So I'm going to stop file. So again, stat stop file. And there we go. So okay, now we want to quit out of this. So I'm just going to quit out of my game. And I'm back in my editor here. And what I want to do is I want to browse to the project's save file. And inside the save file you'll see profiling, Unreal Stats. So, and this is our session here that we just recorded. So inside the Unreal Engine folder, in the same folder that you will find the launcher for the for your editor. So I'm just going to open that file location. You will find Unreal Frontend. Double check you're in the right place, because sometimes you may have more than one version of the engine installed and you want to open up the corresponding front end. So we're just going to open up the front end. I'm going to close that while it's opening. I'm going to copy the directory link to there. And we have Unreal Frontend. So inside our frontend, project launcher, not really interested in that, so we're going to go over to session frontend. So profile, load profile. I believe that's the same directory, but there we go. We're going to open this profile. So give it a minute. It's going to load in all the data. So okay, now we have all the data through. So if you look along the top of the graph here, the main window, where we can scroll along through, and if we notice any particular spikes, as we do here, which I believe is probably when I just turned the corner to have a look at the forest for the first time. What we're really interested in here, folks, is if we go down to the event name, if we look at some of the ones that are taking longer, like we have here task graph thread HP, 34.479 milliseconds, we're not going to actually get too much information by drilling down into this. All we're getting is CPU stall, wait for event. So we're not actually waiting for an event in the blueprints kind of sense. So kind of what we want to kind of focus on is the game thread. So if we expand the game thread, game task graph stalls, CPU stall wait for. So a lot of these we kind of try to ignore, because if we see CPU stall wait for, then that basically means that that isn't our culprit. Our culprit that's costing us time is somewhere else. Now at the moment I'm not too worried about any of these right now. in our render thread, we don't seem to have anything that's particularly out of order. We have nothing in our game thread, but if we had excessive ticks in our game thread, we would see it come up here. Now, with the profile open, I'm just going to place it on a different monitor for now. I'm going to go back to my game view, my actual in editor. I'm going to play in editor, and with this up, I'm now going to bring up game, bring up engine, and I'm going to exit. So, as I said before, while examining your profile view and looking at runtime here in the editor, we are interested in the tick times. So if we look down the bottom again, we have transform or render data, call count 29, and we have blueprint latent actions at 30. So if indeed we were worried about tick events slowing down our game thread, then we're going to have to go in and kind of dig down from those two stats. Also, if I look at blueprint time, call count 18, so that means 18 times in blueprint we're accessing tick, which is probably not the best. So that's in the game stats. If we go down then to engine, and we can look at our average frame time, inclusive average of just under 10 milliseconds, kind of with an inclusive maximum of 14. So they're kind of the stats that we want to keep a look at as we're examining our profile. So once we have a profile gathered, it's important to kind of compare that to the actual in-editor stats and drill down that way. Coming back over to our front end, we can kind of scroll through the graph here, and I believe I was probably walking up to the lake and then back down again. So you can see that there's some spikes here that are occurring, so try and find somewhere where the graphs kind of meet up. So it might be hard to see there, but we have in this area we've quite a large spike, which is represented by this little spike here. So we're going to drill down and see if there's anything in there. Again, we're focusing on the game thread here. If we're doing stuff for GPU and memory, we can do that in engine. What we're worried about here, or what we're looking for here, is there any functions that are delaying our game thread? So game engine tick, world tick time, pre-physics, tick group. So okay, so here we are, landscape, grass update. So I can see that in my functions here that the grass update on my landscape object is taking 10.372 milliseconds. Now you may notice that if we go up to the parent of that, it's 18.721 milliseconds. But there's a cascade effect, not to be confused with the cascade editor, but there's a cascading effect whereby if my grass is updating, then other things within the game thread are waiting for my grass to update. So once it does, we're actually getting more latency on top of that. So that's worth looking at. I have 10.72 milliseconds. So when I looked at this last night, I actually had stuff coming in from my trees, which was a bit of a bummer. I had to cull the amount of trees that were in the area and kind of remove meshes and things. Whereas here we can see that my grass update is costing us a bit more frames. So with that said, let's jump back into the editor. I'm going to reduce that, and because I'm using a procedurally generated grass, not a landscape, but my grass is being procedurally generated and populated onto the landscape with a landscape auto material. What I'm going to do is I'm going to go into the auto material meshes, go to grass, and I have landscape grass types. So if I bring up the landscape grass types, both Again, I'm using source control, so I'm going to have to check these out. So I'm going to check them out. We'll go into our grass. We have a density of 10 in the short grass. And in the long grass, we have a density of 10 as well. So again, I'm just going to go back. I'm going to play an editor so that I get an idea of where or how I want to cull my grass differently. So I'm going to hide all the stats. So as you can see, we have two different streaming distances for our grass. So what we might do to actually increase this is reduce the long grass. If we walk around, yeah, our grass density up close is pretty good. Some of the longer grasses could be culled. So what we're going to do here is these densities are meters squared, so we have 10 grasses per square meter out of all these 8 types. So with a cull distance starting at 500 and ending at 2000. So that starts at 500 and ends at 3000. So what we may do is have ones that cull at a further distance may maintain their density but drop the ones that cull at a lesser distance. So yeah, I'm gonna drop this to 5.0, and I'm gonna do the same all the way down through 50. It's no good. 5.0. I'm going to copy that to speed things up. So okay, so in that example, we identified where on our in our profile was there being some resource hungry bits. We drilled down in the game thread to find the grass update. We then went into our editor, brought out our landscape grass, and changed the grass density per meter squared on one of the grass types to 5 per square meter. So that should have salvaged some of the frames per second. I'm not going to jump into another profile, but that's a good example of how you can use the profiles to actually find out what's going on. So with that said, what we will do is we are going to play an editor. We're going to go into our little our menu. I'm going to stat the memory just to see. Used streaming texture pool is about just under 4 gigabytes. Texture memory used, we've used just over 2.6 gigabytes. So as I said before, we're targeting a machine that probably has 8 gigabytes of system RAM. And if it's a console, it has 8 gigabytes of RAM, which is shared between the system and graphics. But again, some of our users, because we're targeting PC, will have graphics card RAM, so we're going to say about 3 gigabytes. So we're staying well within our margins here. Again, I'm going to hide those stats. We're going to bring up the game stat and the engine stat. And we're going to exit. So, in our call counts, we've seen a slight drop in our call counts now that our grass has been kind of brought down. Our ticks will remain the same, but our call count in the game thread has come down. So, okay, that said, last things last, we're going to hide all our stats again, and this time we're going to put on rendering. And I'm going to exit out of there. So we're watching our draw calls, decals in view, keeping an eye on our stats. Yeah, and I believe culling some of that grass made a huge difference. Again, there's still some savings to be made. We can get rid of a lot more stuff, but it's just a case again of examining your profile, drilling down through it, and seeing what's costing you CPU. Again, the front end session profiling is not great for telling you what's going on the GPU. It's more better for kind of telling you what's going on CPU. For the GPU stuff, you're far better off using the actual commands that are going to tell you a bit more about, you know, your DirectX rendering and things like that. Lighting, shadows, all that kind of stuff. So guys, that's been a quick overview of kind of how to approach optimization, the different stack commands, things to look out for. There's probably a hell of a lot more that you can learn. I'll put some links to some Unreal Engine live streams off their site that I kind of watched, and different kind of places where you can go to find out more stuff about optimization in Unreal. Again, it's something that you want to be doing throughout your project. I personally work on development Monday to Friday. On Friday then I package my builds, and I do any bug fixing and optimization over the weekend, and then I'm back to a regular development cycle on a Monday. Again, it's very important to test on a separate machine other than your workstation. Don't try and emulate hardware for your testing. It's not really worth it. Indeed, if you go into your settings, and down here you'll have engine scalability settings, it really is of limited use. I have my settings generally on high. By default they're going to be on epic. Again, not very useful. You're better off doing your testing on a separate machine with a packaged build, and running your stack commands in there. Recording your profiles, bringing them back to your workstation, drilling down into the data, and trying to make sense of it that way. I don't think there's much to be gained from optimization on your workstation. So with that said, hopefully this was of help to some of you. I know I didn't go through some of the some stuff, but I will leave links to it in the description. So thanks for tuning in, and I'll chat to you all again.